All right, open your interactive notebook to your table of contents. And on page 19, you are going to write greatest common factor and least common multiple. All right, so greatest common factor, least common multiple. If you're not done writing those down, then go ahead and pause the video. And if you are done, go ahead and turn to page 19 in your book and pull out this sheet from your packet of things that you picked up in supply pickup. Cut this sheet out, and then you're going to glue it in to your notebook on page 19. Go ahead and pause your video while you take care of that. All right, welcome back. You should have your piece of paper cut out and glued in on page 19. Make sure you're on the right page. All right, so we're going to talk about greatest common factors and least common multiples today. So the greatest common factor is the factor pairs, all right? You basically find the factor pairs for both numbers. And the greatest common factor, the GCF, is the largest number that is a factor of both numbers, or three numbers, depending upon if you're using more than one. But in terms of fractions, you usually are just dealing with, well, I shouldn't say that. You sometimes add and subtract more than that. So greatest common factor is used when you simplify fractions or when you're making equivalent fractions, okay? So we're going to talk about the greatest common factor first, and then we're going to talk about the least common multiple. I'm going to show you two different ways to solve these problems. One particular way is going to be on this page 19, and the other way will be on the page 20 in just a second. All right, we're going to look for the greatest common factor in the numbers 12 and 9. All right, don't use all the space for these two numbers because we're going to do this twice with a couple different numbers so that you can understand how to do this. So when we list out the factor pairs, what we are doing is we are listing out the numbers that we multiply together to get this number. So we're going to list out all of the different factors. So for 12, generally what you're going to do is you're going to start with 1. And 1 times 12 is 12. So what I do is I write 12 over here because I know those are the pairs, 1 and 12. All right, so as far away as you can. And then we're going to take the next number. The next number that could go into 12 is a 2. So I'm going to write a 2. And then I think to myself, what times 2 is 12? And that's 6. And I'm going to write the 6 over here near the 12. All right, so eventually we'll have a list. And then I'm going to look at 3. And 3 can go into 12 4 times. So I'm going to write a 3. And then a 4. And then the next number up is a 4. And 4 is already here, so I know that I'm done. All right, so first I did 1, and I did 1 times 12. Then I did 2, and because this is an even number, 2 goes into it, so 2 times 6 is 12. And then I went to 3, and I thought about 3, and 3 times 4 is 12. And then I went to 4, and I realized that 4 was already in my list, so I'm done. Now I know there's no more factors of 12. So these are all of the regular old factors of 12. Okay, now I need to do the same thing for 9. So I start out with 1, and I know that 1 times 9 is 9. And then I go to 2. 2 can't go into 9 because 9's an odd number. So then I move on to 3, and I think 3 times 3 is 9, so I only really need to write this down once, all right? And now I am done because 4, well, I can look at 4, but when I was at 3 times 3, once you're close to each other, then you're pretty much done if you've worked your way up and down with that, okay? So now what I do is I have to look for the largest factor that they have in common. So they have they have a 1 in common, but that's not the largest factor. The only time you have a greatest common factor that is 1 is when both of those numbers are prime. And this is not the case because 12 is an even number, and even numbers are never prime because 2 can go into those. So, and just in case you don't remember what prime means the only factors are 1 and itself. So the number 3, the only way I can get to 3 is 1 times 3 or 3 times 1. There's not any other number that is a factor of that. Okay? So now I look at this and I look for the greatest common. So the next one is 3, and actually 12 has a 3 too. And the next one's 9. 9 doesn't go in. So 3 is the largest, the greatest number that is common between those. Okay? Let's look at 27 and 42. All right, as I do 27 and 42, I'm going to list out my numbers again. So I start out with 1. 1 times 27 is 27. 2, this is an odd number, so 2 does not go into 27. 3 times 9, I know, is 27. This works and is a lot quicker if you actually know your multiplication facts. 4 cannot go into 27. 5 cannot go into 27. 6 doesn't go into 27. 7 doesn't go into 27. 8 doesn't go into 27. And now I'm back up to 9. So I know there's nothing else in between. Okay? So I have 1, 3, 9, and 27. 42 is an even number. So we know that there's 1 and 42. And then we know it's an even number, so 2 is going to go into it. 2 goes into 42 21 times. 3, if you add the digits in a number together, 4 plus 2, that's 6. If 3 goes into the added up version of this, then it is a factor. So it's divisible by that number. So 4 times 2 is 6. So I know that 3 goes into 6 evenly. So 3 is a factor of 42. So I'm going to put a 3 here. And can you get that? And we will 3 times 14 is the next number. 3 times 14 is 42. And then 4 does not go in evenly. 5 doesn't end in a 5 or a 0. It doesn't go in equally. 6, I know that 6 times 2 is 40. 6 times 7 is 42. So I'm going to do 6 and 7. All right, and because those two are right next to each other, I don't have to go any further. I've gone through all of the numbers that it could possibly be. All right, now we're going to take a look at these. I have 1, 3, 9, and 7, and I'm going to look for common factors. All right, and the only common factors that I see are 3. So this is the greatest common factor for 27 and 42. Just so happens to be the same one that we had above. All right, so our GCF here is 3, and our GCF here is 3. All right. Now, least common multiple. Least common multiples are used to find your common denominators when you add and you subtract fractions, all right? And you're going to multiply each number. Sorry about that. You're going to multiply each number by 1, 2, 3, 4, 5 until you get common products of both numbers. Okay? So I start with 12 and 9. And then I multiply. Well, 12 times 1 is 12. And then 12 times 2 is 24. And then 12 times 3 is 36. And then 12 times 4 is 48. And I'm just going to stop there to see. If I know my multiplication facts, I already know that 9 goes into one of those. If I don't know my multiplication facts, I might keep going. So knowing your multiplication facts will help you stop earlier. So I know 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. And 9 times 4 is 36. So as soon as I get that common number, then I know that I have my LCM. So my LCM for 9 and 12 is 36. All right, so if I was adding fractions, my common denominator would be 36. Okay, 27 and 42. Now this is an example of one where what I'm going to share next is going to make all of this so much easier, because this is a really long list that we're going to have to do with 27 and 48. So the larger the denominators are, the longer it's going to probably take you to find a common multiple. Okay? And multiples mean the number multiplied times each you're counting by. Like if you were counting by 2s, those are 2, 4, 6, 8. Those are multiples of 2. All right, but we're trying to find the common multiple between two numbers. So I'm going to start by listing out, I'm going to go ahead and start by listing out the 48s first, because it's a larger number, and I will get to larger numbers sooner, and the 27 might show up in those. May work sometimes, may not work other times, but it's a strategy I like to use. So 48 times 2 is 84. 42 times 3 is 126. 42 times 4 is 168. 42 times 1, 2, 3, 4, 5 is 210. Times 6 is 252. Times 7 is 294. Times 8 is 336. Times 9 is 378. And times 10 is 400 and, oops, we're doing 2 here, sorry. 420. All right. Now, I'm going to stop there because we're 10 up. I may have to go further if I can't find one of the multiples of 27 that matches. So far, we've written out 10 numbers. Okay, that's a lot of work to find a least common multiple. So I'm going to show you a strategy after this that's going to make it a little bit simpler. So 27 times 2 is 54. 27 times 3 is 81. Times 4 is 108. Times 5 is 135. Times 6 is 162. 7 is 189. 8 is 216. 9 is 234. 10 is 270. 11 is 290. Notice I'm only here. Don't have a common yet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12 times 12 is 324. And I'm going to slide down this direction. Times 13 is 351. And times 14 is 378. All right. If you notice, we have 378 over here. and 378 there. So the least common multiple is 378. So if I was adding, 8 27ths and 4 42nds, in order to add those numbers together, I would have to make them over a fraction of 378. Okay? This was a long, laborious job of listing out these numbers. Okay? So I'm going to give you an easier way to figure that out on your next page. So finish writing that down and then turn your page. All right, at the top of your page, I want you to write greatest common factor, least common multiple. All right, one of my old 6th grade students taught me this, and it is phenomenal. So if you can learn how to do it and memorize it, it will help you a lot in all of your work from now until you graduate from college, actually, if you have to take math classes in college. So what you're going to do is you're going to kind of make an upside down division problem. All right, so I'm going to draw a box that looks like this, and I'm going to put the 2 numbers that we used earlier inside. So we used a 9 and a 12 first. All right, so we already know that the GCF is 3 because we did this over here. But I'm going to show you how much simpler this is. So what you do is you take prime numbers. All right, and as I said a minute ago, your prime numbers are the numbers that only have a factor of 1 and itself. Okay, so the first prime number is 2. 2 can be divided into 1 times 2. All right, that's it. That's a prime number. So 2 is a prime number. I'm going to list them down here. Prime numbers. 2. 3 is the next prime number. 1 times 3 is 3. There's nothing else that gets you there. 4 is not a prime number because 1 times 4 is 4 and 2 times 2 is 4. 5 is a prime number. 1 times 5 is 5. 6 is an even number, not prime. So any even number is never prime. 7 is your next prime number. All right. 8 is not prime. 9 is not prime because 1 times 9 is 9 and 3 times 3 is 9. So 9 is not prime. 10 is not prime because it's even. And the next prime number after that is 11. You can Google and see, if you just Google chart of prime numbers, they'll list them out for you, like up to 100 prime numbers. For our sake, we really only need these. So just have this list off to the side. So you always start with the 2 and you work your way down. So I ask myself, can 2 go into 9 and 12? Can it go into both of those numbers? It cannot because 9 is an odd number. So I skip 2. Okay? And now I move down to 3. Can 3 go into 9 and 12? 3 goes into 9 and it goes into 12. So I write 3 out here. And then I divide. 3 goes into 9. How many times? 3. And I write the answer underneath. Okay? 3 goes into 12. How many times? 4. And I write the answer underneath. Okay? Then I look at the numbers that are the answers that are under here. And I say, can 3 go into this number? Either of those numbers again? No, it cannot. It can't go into both of them. Can 5 go into both of them? No, because it's larger. So now I'm done. All the prime numbers are larger than the numbers that I have left. Okay? Now, 3, the number that is right here. I wish I would have brought a different colored pen. Let me pause for just a second. Okay. So 3, right here, the number that's right out here or on this side, I'm going to show you some where there's more than one number and you have to multiply them together. But whatever's left on the side over here, is your GCF. So we found out that 3 was the GCF over here by listing out your numbers. Here's GCF, okay? Your LCM, okay, your least common multiple, are these numbers. 3 times 3 times 4. Okay, so 3 times 3 is 9, and 9 times 4 is 36. So our LCM is 36. Okay? And then the numbers that are right here, that's our reduced fraction. That's our simplified fraction. So we know that our GCF is 3. Our LCM, you can see the L to kind of help you remember, is every number here that goes around in that L multiplied together. So 3 times 3 is 9, times 4 is 36. And then the simplified fraction of 9/12 is 3/4. All right? So you get all of this information from this little bit of work versus listing out all the things we listed out over here. All right, specifically this problem here, down here for this LCM. All right. So let's try another problem. And we'll actually do the one that listed out all the long ones. So let's do 27 and 42. Draw out the little upside down division. And we're going to start with our prime numbers. I start with a 2. 2 cannot go into 27 because 27 is an odd number. So then I move on to 3. Can 3 go into 27 and 42? It can. So if I add 2 plus 7, I get 9, and 9 divided by 3 is 3. If I add 4 plus 2 together to get 6, and divide 6 by 3, I get 2. So we end up with, those are divisible by 3. All right, so 3 goes into 27 9 times, and 3 goes into 42 14 times. All right, now I move down. Can 3 go into 9 and 14? No, because 3 does not go into 14. So I move on to the 5. 5, these don't end in 0 or 1 or 5. So 5 is not divisible by, they are not divisible by 5. 7 does not go into 9 evenly, and 11 is greater than 9. So we are done. Okay. So our GCF is 3. Our LCM is 3 times 9 times 14. And when we take 3 times 9 times 14, we get 378. And then our simplified fraction is 9/14. Okay, we got all of this information from this little bit of work versus all of this listing numbers out to get to our LCM. Okay, even here, when we listed out the numbers, we had to list all the factors. That was still more work than what we did right here. All right. try another number. Currently, so far, these two, we've only had one number off to the side. I'm going to do one more like that, and then we'll do one where there's more numbers, and you can see how that's done. All right, our next number will be 28 and 50. Okay, I'm going to start off with 2. And 2 can go into 28 14 times. And 2 goes into 50 25 times. All right, 2 can't go into 25, so I have to move on to 3. 3 can't go into 14 evenly, so I know to move on. 5 can't go into 14 evenly, so I know I can move on. 7 goes into 14 evenly. 7 times 2 is 14, but it does not go into 25, so I can move on. And 11 doesn't go into either number. Then I would move on to my next one, which is 13. 13 can't go into 14 evenly or 25. And then 13, the next prime number is 17, and that's larger than 14, so we know we're done. All right, so looking at this, our GCF is 2. Our LCM is, let me use the orange, is this L multiplied together. So that means 2 times 14 times 25, and that equals 700. So our least common multiple, the smallest number that 28 and 50 both go into, is 700. And then our simplified fraction is 14/25, if what we were doing was trying to find a simplified fraction for 28 and 50. Okay? So the simplified fraction of 28 over 50 is 14/25. Okay? Last one for today. And this one will have more than one number on the side for the GCF, so you can see how that works. So we're going to do 36 and 48. Okay? So I make my little thing. I'm going to start off again with the 2. And because both of these numbers are even, I know that 2 goes into both of these numbers. 2 goes into 36 18 times, and 2 goes into 48 24 times. Okay? Now I look at them again. 18 and 24 are both even numbers, so I know 2 goes in again. So I draw another line down, and then I put a 2 outside. And now I do exactly what I just did. 2 goes into 18 9 times, and 2 goes into 24 12 times. Okay? Now I think to myself, can 2 go into 9? It cannot, so I move on to 3. Can 3 go into 9 and 12? It can, so I draw another line down, and I make a 3. So 3 goes into 9 3 times, and 3 goes into 12 4 times. All right. So now our GCF, all the numbers that are on the side here, have to be multiplied together to get the GCF. Okay, to get the greatest common factor. So 2 times 2 is 4, times 3 is 12. So my GCF is 12. 2 times 2 times 3. All right, this dot, when you get to middle school, this is what you want to use for multiplication so that you don't confuse the x with a variable when you do algebra. So the GCF is 12. The LCM is all of these numbers added, multiplied together. So we already know this is 12, so then 12 times 3 times 4. And that equals 144, which 12 times 12. So you can kind of gather them together and multiply them to get, like, 3 times 4 here is 12. And we know that 2 times 2 times 3 is 12, so we can say 12 times 12 is 144. Or we can say 2 times 2 is 4, times 3 is 12, times 3 is 36, times 4 is 144. So 2 times 2 times 3 times 3 times 4 is 144. And then if we had a fraction that we were trying to simplify, so simplified fraction, and our original fraction was 36 over 48, the simplified fraction would be 3/4. All right. Okay, you are going to do a short little assignment based on greatest common factor and least common multiple. And we will be doing this today and tomorrow. So tomorrow you won't have a sheet that goes into your interactive journal, but you will have some more practice. So if you are confused, look back over this. And if you need more help, then give me a message and we can get on Zoom and I can help you with that. All right.